Hey guys, today we're going to talk about analyzing graphs and being able to describe them. And so the first thing that we want to be able to do is to look at a part of the graph and decide, is it linear or nonlinear? Is it increasing or decreasing? So if we look at the first part of the graph, if I look at this part of the graph, those are actually the y values for the x values that are just below 4. Okay, not quite 4, but just below that. And so if we were going to describe that, the x value, it's less than 3.9. And it's also greater than 0, and we could write that at the same time. So this inequality says 0 is less than x is less than 3.9, but we can look at that in pieces. If we read this backwards, this says x is greater than 0. This part says x is less than 3.9, okay? And if we look at what's happening with the graph in between there, we see that those y values are going up. So it is increasing. And we also see that it's not a straight line, so it is nonlinear. And if we wanted to be more specific, if I look as x increases by 1, if I look at my y's, the amount that y is increasing by is increasing each time. And so we would say that it is increasing at an increasing rate. Now, your standard says that you need to be able to say that it's increasing and it's nonlinear, so that increasing at an increasing rate would be going a little bit past that, okay? So if we look at A says between x is 3.9, so here's where x is 3.9. Remember, if we could draw a line down if that helped us. And x is 6.9, so x is going to be just below 7. So there we're looking at something right there. So now I'm describing that section of the graph that's labeled B. Well, we see that it's going up, so it is increasing, and it is linear. So if we were going to answer A, we would need to be able to say that it is increasing and that it is also linear. Okay, between 6.9 and 9 for part B, right? So there's 6.9, here's 9. It is also increasing, and it is linear. Now, if we're going to compare or which piece this person was traveling the fastest between the section of the graph labeled B and the section of the graph labeled C, if we're thinking about what part that they were going faster, it would be C. Remember earlier this year we talked about steepness, and the steeper we see on the graph, the faster that change is happening. Okay, if we look at the section of the graph labeled D, then it is linear because it's a straight line, but it's neither increasing or decreasing. That distance is remaining constant during that part, okay? So if we were answering C, between x is equal to 9 and 15.1, here's 15.1, so this part, it is linear, it's a straight line, but it's neither increasing or decreasing, because at that point that value is constant, okay? And then I want us to look at this next part. Okay, the part D in the question says when x is greater than 15.1, and this part starts out linear, but then it changes. And so if we were going to have to describe this entire thing, we would have to say it's nonlinear, even though part of it is. And It's going down, so it is decreasing. Okay. And down here at towards F, what I want you guys to see is it is decreasing, but the amount it's decreasing is getting smaller each time. So if we were only describing part F, we would say that it's decreasing at a decreasing rate. Now again, your standard, you need just to be able to tell me that it's decreasing and that it's nonlinear, but there's an extra bit for you to think about. So another thing that I want you guys to think about with this graph is, why on earth would we have a graph that looks this way? We're talking about time on the x-axis, and we have distance measured on the y-axis, and we don't have units of measure of any of those. But maybe someone is going to the park. Maybe as they start their trip, they're working their speed up, getting faster and faster. Then maybe they are not going quite as fast as they just were, but they're going at a constant rate at B. Then they speed things up a little bit during part C. And then D, they stop. Why on earth would they stop? Maybe they got to the park and they're just hanging out at the park. Maybe this person was going back to school and they got to school, and so now they're not on their bike at all. And so that distance isn't changing. And maybe E is them coming back home from the park or school or wherever they were going. And we see that distance is going down. So actually, if we were thinking about this distance, maybe this distance is their distance from home. But it wouldn't be their total distance, because their total distance wouldn't decrease. So when we're looking at graphs, we always need to be considering what the axis is representing and then what's really happening on the graph. Thanks, guys.